You are watching channel Number Collage. Through this channel, we make sincere efforts to make you understand and like mathematics in a simple and easy manner. We need your cooperation in this regard.
In this video, we will understand about the nth term of an AP. Now, what is nth term? Nth term is any term of the AP which is placed at nth position of the AP, where n is a positive integer. The most general form of an AP is given as A plus T, A plus 2D, A plus 3D, A plus 4D, so and so forth. Here, the first term is written. The second term is obtained by adding the common difference D to the first term. Third term is obtained by adding the common difference D to the second term. The fourth term is obtained by adding common difference D to the third term, so and so forth. Now, in order to get the nth term of the AP, we will rewrite all these terms in a different manner. So, let us rewrite the terms as: the first term we write as A1 equals A plus 0 times T, where the 0 we will write as 1 minus 1. The second term A2 we write as A plus 1D, and this one we will write as 2 minus 1. Third term A3 we will write as A plus 2D, and this 2 we will write as 3 minus 1. The fourth term A4 we write as A plus 3D, where this 3 we will write as 4 minus 1, and so forth. Here we observe that this 1 becomes 1 minus 1, this 2 becomes 2 minus 1. In A3, this 3 becomes 3 minus 1. In A4, this 4 becomes 4 minus 1, so and so forth. In case of nth term, this n becomes n minus 1. So, our nth term will be an equals A plus n minus 1 into t. So, this is the nth term, or the general form of nth term of an AP. Now we will solve some examples based on nth term of an AP. Find the 10th term of the AP 2, 7, 12, so and so forth. 10th term of this AP means the term of this AP which is placed at 10th position. First, we will write the first term, which is 2, then the common difference D, which is 7 minus 2, which will be 5, and n equals 10, because we have to find the 10th term. Now we have the general form of nth term as an equals A plus n minus 1 into t. Now we will substitute the values for finding the 10th term of the AP. So we have A 10. So in place of n, we have put 10 here. So we get A10 equals 2, which is A, the first term, and n minus 1. In place of n, we have put 10 here, and in place of D we have put 5 here. So we get 2 plus 10 minus 1 is 9. 9 5s is 45. So 2 plus 45 is 47. So we get 10th term of this AP as 47, which means that 47 is the term of this AP which is placed at 10th position. Which term of the AP 21, 18, 15, so on and so forth is minus 81? Also, is any term 0? Give reason for your answer. Now here we have to find the position in which minus 81 is placed in this AP. That means we have to find the value of n. Also, we have to find if any of the terms of this AP is going to be 0, and if at all there is a term 0 in this AP, then we have to provide a reason for our answer. First, we will write the first term, which is A equals 21, the first term. Then we write common difference D, which will be 18 minus 21 minus 3. Now, since we have to find the position of minus 81 in this AP, we will assume minus 81 to be the nth term of this AP. So we write AN equals minus 81. Now we have the nth term as AN equals A plus n minus 1 into D. Now we will substitute the values. AN is minus 81, A is 21, and minus 1 into D. D is minus 3. We will take this minus 21 to the left hand side and write n minus 1 multiplied by minus 3 equals minus 81. 21 when goes to the left side, it will become minus. Minus 81 minus 21 is minus 102. Now we will divide by minus 3. So n minus 1 will be minus 102 divided by minus 3, which will be 102 divided by 3, which will be 34. So we get n equals 34 plus 1, which will be 35. It means that 35th term of this AP will be minus 81. Next, we have to find whether any of the terms of this AP will be 0. So we will start by assuming nth term of the AP to be 0. So we write A plus n minus 1 into D, which is our nth term, equals 0. Now we will substitute the values. We will write 21 for A and minus 3 for D. Next, we will take 21 to the right hand side and write n minus 1 multiplied by minus 3 equals minus 21. Now we will divide by minus 3 and write n minus 1 equals minus 21 divided by minus 3, which will be 7. So n will be 7 plus 1, that is 8. So we conclude that the 8th term of this AP will be 0. So this is our reason. Determine the AP whose 3rd term is 5 and the 7th term is 9. The general form of nth term of an AP as AN equals A plus n minus 1 into D. Now we are given the third term to be 5. So we write A3 equals 5. Now, according to this general form, we write A3 as A plus 3 minus 1 into D, because n here is 3, which equals 5, because third term is 5. So we will get A plus 2D equals 5. Now the seventh term is given to be 9. So we write A7 equals 9. In place of A7, we will write A plus 7 minus 1 into D equals 9, which will be A plus 60 equals 9. Now we have these two equations. A plus 2D equals 5 and A plus 60 equals 5. Now these are linear equations in two variables A and D. We can solve these two equations and find the values of A and D. Now here we will subtract the second equation from the first equation, so that we will get A minus A equals 0, 2 minus 6 will be minus 4, and 5 minus 9 will be minus 4. So we get minus 4D equals minus 4, which will be 4D equals 4, that is D equals 1. So we got the common difference D as 1. Now we will substitute the value of D in the first equation and find the value of A. So we get A plus 2 times D, which is 1 here, equals 5, which will be A, it will be 5 minus 2, 3. So the first term is 3. Now we have the first term as 3 and the common difference D as 1. Now the most general form of AP is A plus D, A plus 2D, A plus 3D, so on and so forth. Now we will substitute the values of A and D in this general form and get the AP that we want. So the AP will be 3, because A is 3, then 3 plus 1, because D is 1, then 3 plus 2 times 1, because D is 1, 3 plus 3 times 1, 3 plus 4 times 1, so on and so forth, which will be 3, 4, 5, 6, 7, so on and so forth. So this is the required AP which we have determined. Check whether 301 is a term of the list of numbers 5, 11, 17, 23, so on and so forth. Here we have to find out whether the number 301 belongs to this AP. Now 301 will belong to this AP only if n is a positive integer. Here A is 5, the first term. Common difference D is 11 minus 5, which is 6. Since we have to find whether 301 is a term of this AP or not, we will assume 301 as the nth term of this AP. So we write AN equals 301. Now we have nth term AN as A plus n minus 1 into D. Now we will substitute the values. AN is 301, A is 5, and D is 6. first we will take this 5 to the left hand side and write n minus 1 into 6 equals 301 minus 5, which is 296. Now we will divide 296 by 6. So we write n minus 1 equals 296 divided by 6, which will be 2 3s are 6, 2 1s are 2, 2 4s are 8, and 2 8s are 16. So n minus 1 is 148 divided by 3. So n will be 148 divided by 3 plus 1, which will be 148 plus 3 ones are 3, that is 151 divided by 3. Now 151 divided by 3 is not a positive integer, therefore we can infer that 301 cannot be a term of this AP, because we know that for an AP the value of n or n is always a positive integer, but here we do not get n as a positive integer. How many two-digit numbers are divisible by 3? Now, two-digit numbers range from 10 to 99, out of which we have to write those two-digit numbers which will be divisible by 3. So the two-digit numbers divisible by 3 will be 12, 15, 18, 21, so and so forth, 99. Here the first term A is 12. The common difference D is 15 minus 12, which will be 3. Now here the last term is 99. So we will assume 99 as our nth term. So an is 99. Now we have to find how many such two-digit numbers. So therefore we have to find n. Now we have nth term as an equals a plus n minus 1 into d. We will substitute the values. For an 99, for a 12, and for d 3. We will take this 12 to the left hand side and write 99 minus 12. This 12 goes to the left hand side, so it becomes minus. So 99 minus 12 will be 87. Now we will divide 87 by 3. So n minus 1 will be 87 divided by 3, which will be 29. So n will be 30. Therefore, there will be 30 two-digit numbers divisible by 3. Find the 11th term from the last term of the AP 10, 7, 4, so and so forth, minus 62. Here, please note that we have to find the 11th term from the last term, which means we have to start counting in the reverse order. Now for this AP we have common difference D equals 7 minus 10, which will be minus 3. Now by using this common difference we will write 3 more terms in the last section of this AP, and we will write these extra terms. The term before minus 62 will be minus 59, because minus 59 plus minus 3 will be minus 62. The term before minus 59 will be minus 56, because minus 56 plus minus 3 will be minus 59. Now we have to write this AP in the reverse order, because we have to find 11th term from the last term. So starting from minus 62, our AP will be minus 62, minus 59, minus 56, minus 53, so on and so forth, 4, then 7, and finally 10. Now for this AP we have common difference D equals minus 59 minus of minus 62 minus 59 minus of minus 62, so which will be minus of minus 62 will be 62 minus 59, which will be 3. A.N will be A plus n minus 1 into D. Substituting the values, A is minus 62 plus n is 11 minus 1 multiplied by D, which is 3. We get A11 equals minus 62 plus 11 minus 1 is 10. 10 multiplied by 3 is 30. So minus 62 plus 30 will be minus 32. So the 11th term from the last term of this AP will be minus 32. Find the 31st term of the AP whose 11th term is 38 and 16th term is 73. We have to find the 31st term, so we write A31 equals question mark. Now 11th term is given to be 38, so we write A11 equals 38, and 16th term is 73, so we write A16 equals 73. Now A11 becomes A plus 11 minus 1 into D equals 38, which will be A plus 10D equals 38, and A16 becomes A plus 16 minus 1 into D, which is given to be 73, so it becomes A plus 15D equals 73. Now this equation and this equation, they are the linear equations in two variables A and D. So we have to solve them. We will bring A plus 10D equals 38 and write here. Now we will solve these two linear equations. We will change the signs of the second equation and write plus A as minus A, plus 10D as minus 10D, and plus 38 as minus 38. Now A minus A will be 0, 15D minus 10D will be 5D, and 73 minus 38 will be minus 35. So 5D will be 35 and D will be 7. Now we will substitute the value of D in the first equation here and write in the second equation here and write A plus 10 times D, which is 7, equals 38, which will be A plus 70 equals 38. So A will be 38 minus 70, which will be minus 32. Now we have A equals minus 32 and D equals 7. So we can write the 31st term as A31 equals A plus 31 minus 1 multiplied by D. Now we will substitute the values of A and D. We have A equals minus 32 and D equals 7. which will be minus 32 plus 30 multiplied by 7 is 210, and 210 minus 32 will be 178. So this will be our 31st term. An AP consists of 50 terms, of which third term is 12 and the last term is 106. We have to find the 29th term. Now since the AP consists of 50 terms, we have n equals 50. The third term is given to be 12, so it will be A3 equals A plus 3 minus 1 into D, which will be A plus 2D, and it is given to be 12. So we have A plus 2D equals 12. Now next, last term is 106. So we write A50 because total number of terms are 50. So the last term will be A50, which will be A plus 50 minus 1 into D, which will be A plus 49D, and it is given to be 106. Now we have two equations, A plus 2D equals 12 and A plus 49D equals 106, which are linear equations in two variables. We have to solve them and find the value of the 29th term. So we will solve these two equations. So first write A plus 2D equals 12 and A plus 49D equals 106. Now we will subtract the second equation from the first equation. So we will change the signs of the terms of the second equation. So we will write plus A as minus A, plus 49D as minus 49D, plus 106 as minus 106. Now A minus A will be 0, 2D minus 49D will be minus 47D, and 12 minus 106 will be minus 94. So we get 47D equals 94, which will be D equals 94 divided by 47, that is 2. So we got D equals 2. Now we will substitute the value of D in one of these equations. Let us put this value of D in the first equation. So we write 2 in place of D. So we get A plus 2 times 2 equals 12, which will be A equals 12 minus 2 2s are 4, which will be A. So we have A equals 8 and D equals 2. So with the help of these two values, we will write the 29th term as A29 equals A, the first term, which is 8 plus n minus 1. Now n is 29 multiplied by D, which is 2. It gives us 29 minus 1, 28 multiplied by 2. So it will be 8 plus 28, 2s are 56. 8 plus 56 is 64. So we get the 29th term of the AP as 64. If the third and the ninth terms of an AP are 4 and minus 8 respectively, then we have to find which term of this AP is 0. Now here third term is given to be 4, so we write A3 equals A plus 3 minus 1 into D, which will be A plus 2D, and it is given to be 4 here.
and ninth term is minus 8. So we write A9 equals A plus 9 minus 1 into D, which is A plus 8D, and it is given to be minus 8. Now we have to find which term of this AP is 0. That is, we have to find n. And since we do not know which term of this AP is 0, so we will assume that term which is 0 to be an and write an equals 0. Now we have a plus 2d equals 4 and a plus 8d equals minus 8. These two linear equations in two variables a and d. After solving these two equations, we will get the values of a and d and will be able to find the value of n. So let us first solve these two linear equations. Now we will subtract the second equation from the first equation. For that, we have to change the signs of each term of the second equation. So we will write plus a as minus a, plus 8d as minus 8d, and minus 8 as plus 8. Now a minus a will be 0, 2d minus 8d will be minus 6d, and 4 plus 8 will be 12. So d will be 12 divided by minus 6, which will be minus 2. Now we will substitute the value of d equals minus 2 in the first equation. So we will replace this d by minus 2 and write a plus 2 multiplied by minus 2 equals 4, which will be a plus minus 4 equals 4, which will be a equals 4 plus 4, that is 8. So we got a equals 8 and d equals minus 2. Now by using the values of a and d, we will find the value of n. Now we have an equals 0. So we write a plus n minus 1 into d equals 0. We will substitute the values of a and d. We will write a equals 8 and d equals minus 2. We will send this 8 to the right hand side, so it will become minus 8, and minus 2 multiplied by n minus 2n minus 1 multiplied by minus 2 plus 2. We will send this 2 to the right hand side, so it will be minus 2n equals minus 8 minus 2, which will be minus 10. So 2n will be 10 and n will be 5. So we can say that fifth term of this AP will be 0. So fifth term of the given AP or the AP will be 5. The 17th term of an AP exceeds its 10th term by 7. We have to find the common difference. Here, the relationship between the 17th term and the 10th term has been given. So we write A17 equals A10 plus 7. That is, 17th term exceeds the 10th term by 7. We write A17 minus A10 equals 7. Now, in place of A17, we will write A plus 17 minus 1 into D, and in place of A10, we will write A plus 10 minus 1 into D equals 7. Now we will simplify this expression. So we get A plus 16D minus A minus into plus will be minus 10 minus 1 will be 9. So minus 9D equals 7. Now A minus A becomes 0 and 16D minus 9D will be 7D. So we have 7D equals 7, that is D equals 1. Two A.P.s have the same common difference. The difference between their 100th term is 100. What is the difference between their 1000th terms? Here there are two A.P.s. Therefore, we will use different notations for different A.P.s. So we write capital A100 for the first A.P., which is equal to capital A plus small n minus 1 into D. Here n and D will not change because they are same for both the A.P.s. For the second A.P., we write small a100 equals small a plus n minus 1 into D. Now the difference between the 100th terms is 100. So we write A100 minus capital A100 minus small a100 equals capital A plus 100 minus 1 into D. For this capital A100 minus small a plus 100 minus 1 into small d, which is given to be 100 here. We will simplify this. It will be 100 minus 1 will be 99d, 100 minus 1 will be minus 99, because this minus plus 99 will be minus 99. So here 99d minus 99d will be 0 and we get a minus a equals 100. Now we will find the difference between the 1000th terms. So it will be capital A 1000 minus small a 1000, which will be capital A plus 1000 minus 1 into D minus A plus 1000 minus 1 into D. We will simplify this. So it will be 1000 minus 1 will be 999 D and 1000 minus 1 will be 999 D, and because of this minus it will be minus 999 D. Now 999 D minus 999 D will be 0 and we get A minus A, but A minus A is 100, which we have already found out. So we can write the difference between the 1000th terms of 2 A.P. to be equal to 100. How many 3-digit numbers are divisible by 7? Now 3-digit numbers range from 100 to 999, out of which we have to write only those 3-digit numbers which are divisible by 7. So such 3-digit numbers will be 105, 112, 119, so and so forth, and the last 3-digit number divisible by 7 will be 994. Now here for this A.P., A equals 105, D equals 112 minus 105, that is 7. And we will assume the nth term to be the last term, which is 994. So we write A.N equals 994. We have A.N equals A plus and minus 1 into D. We will substitute these values here and write 994 in place of A.N equals 105, which is A plus and minus 1 into D, which is 7. We will take this 105 to the left hand side and write n minus 1 into 7 equals 994 minus 105, which will be 889. Now we will divide 889 by this 7 and write n minus 1 equals 889 divided by 7, which will be 7 ones are 7, 7 twos are 14, and 7 sevens are 49. So n will be 127 plus 1, that is 128. So there will be 128 three-digit numbers divisible by 7. For what value of n are the nth terms of the two A.P.s 63, 65, 67, so on and so forth, and 3, 10, 17, so on and so forth are equal. Here we are given two different A.P.s whose nth terms are given to be equal, and we have to find the value of n. We will write the values of A, D and A.N separately for these two A.P.s. So for the A.P. 63, 65, 67, we have A equals 63, D equals 65 minus 63, which is 2, and A.N is 63 plus and minus 1 into D. 63 is first term A and D is 2. For the second A.P. 3, 10, 17, we have A equals 3, D equals 10 minus 3, which is 7, and A.N will be 3 plus and minus 1 into 7, where A is 3 and D is 7. Now we will equate the nth terms of these two A.P. and write 63 plus and minus 1 into D, which is this, equals 3 plus n minus 1 into 7, which is this. Next, n into 2 will be 2n, minus 1 into 2 will be minus 2, n into 7 will be 7n, minus 1 into 7 will be minus 7. Now we will bring the terms 2n and 7n together and write 2n minus 7n. This plus 7n, when comes to the left hand side, it will become minus, and 3, which is this 3, minus 7, which is this minus 7. This 63, when goes to the right hand side, it will become minus 63. This minus 2, when goes to the right hand side, it will become plus 2. 2n minus 7n will be minus 5n, and 3 plus 2 will be 5, minus 7 minus 63 will be minus 70, 5 minus 70 will be minus 65. So we have minus 5n equals minus 65, which means 5n equals 65. Therefore, n will be 13. So, for n equals 13, the nth terms of these two APs will be equal. Find the 20th term from the last term of the AP, which is 3, 8, 13, so on and so forth, to 53. Here, common difference D is 8 minus 3, which is 5. So with the help of this common difference, we will write last three terms of this AP. So we will write 3, 8, 13. Now 253, which is the last term, minus 5 will be 248. 248 minus 5 will be 243. 243 minus 5 will be 238. Now we have to find the 20th term from the last term. So we will write this AP in the reverse order so that 253 will become the first term of the AP. And so we will write the AP in the reverse order. 253, which is the last term, 248, which is the last but one term, 243, a term before that, so on and so forth, 13, 8, 3. Now we have for this AP, A equals 253, D equals 248 minus 253, which is minus 5. Now with the help of A equals 253 and D equals minus 5, we will write the nth term of the AP as A plus and minus 1 into D. We will substitute the values. We have to find 20th term, so we will write 820 equals, we have A equals 253 plus we have n equals 20, so 20 minus 1 multiplied by D, we have D equals minus 5. Next, 253, 20 minus 1 is 19, 19 multiplied by 5 or 19 multiplied by minus 5 will be minus 95, and 253 minus 95 will be 158. So the 20th term from the last term of this given AP will be 158. Now we will solve one descriptive problem. Subbarao started work in 1995 at an annual salary of rupees 5,000 and received an increment of rupees 200 each year. In which year did his income reach rupees 7,000? Here, in 1995, his annual salary was rupees 5,000. So we have the first term of the AP, A equals rupees 5,000. Now each year he is getting an increment of rupees 200. So that is going to be our common difference D. So D will be rupees 200. Now we have to find in which year his salary is going to be rupees 7,000. So we will assume rupees 7,000 to be the nth term of the AP. So we have AN equals rupees 7,000. Now in order to find in which year his salary is going to be rupees 7,000, we have to find the value of N. So we will write the nth term of this AP as AN equals A plus and minus 1 into D. Now we will substitute the values. 7,000 for AN, 5,000 for A, you have to find N. and 200 for D. We will take this 5000 to the left hand side and write n minus 1 into 200 equals 7000, which is this one, minus 5000. When this 5000 goes to the left hand side, it will become minus. Now 7000 minus 5000 becomes 2000. Now we will divide this 2000 by this 200 and write n minus 1 equals 2000 divided by 200. So these two zeros will get cancelled with these two zeros, and two ones are, two tens are. So we get n minus 1 equals 10, that is n equals 11. Now we will start counting from the year 1995 including, and if we go on counting 95, 96, 97, so and so forth up to the 11th year, we will reach the year 2005. So that gives us the answer that in 2005 his income will be rupees 7,000. Let us solve another descriptive question. Ramkali saved rupees 5 in the first week of a year and then increased her weekly savings by rupees 1.75. If in the nth week her weekly savings became rupees 20.75, we have to find n. So in this question, Ramkali saved rupees 5 in the first week suggests that the first term of the AP will be rupees 5. So A is rupees 5. Then increased her weekly savings by rupees 1.75, which means the common difference in this case will be D equals rupees 1.75. In the nth week, that means in the last week, her weekly savings become rupees 20.75, which means the nth term of this AP will be rupees 20.75. And we have to find n, which means in which week her income will become rupees 20.75. So we will write the formula for nth term, which is a plus n minus 1 into d. We will substitute the values 20.75 for an, 5 for a, and 1.75 for d. First we will take this 5 to the left hand side, so it will become 20.75 minus 5, which will be 15.75. After that we will divide this 15.75 by 1.75. So n minus 1 will become 15.75 divided by 1.75. We will write this ratio as 1575 divided by 175. 1575 becomes 25 multiplied by 63 and 175 becomes 25 multiplied by 7. This 25 will get cancelled with this 25 and 7 9s are 63. So we get n minus 1 equals 9. So the value of n will be 10. So this is about nth term of an AP. If you liked this video, please click like and share this video to the students of class 10 and their parents. Please subscribe this channel. This will motivate us to make more and more simple videos for your benefit. So press the subscribe button. Thanks for watching and have a nice day.